Hello everyone. Okay, so I've been working on a new release for Cerebral with a brand new feature which is just called Snapshot Testing. You might know Snapshot Testing from React using Jest. Basically, you take a snapshot of the UI, and if it changes, you are notified about it. So you don't write all the expect and all the assertions. It kind of just produces a snapshot of the UI, and if it changes, it notifies you. And we can actually do the same thing with Cerebral signals. So what we're going to do here now is just to give you an overview of how it works. I fired up the to-do MVC application, and we can see here in my app.test file, I have a test. Should filter on all. Okay, so if we look into the debugger, we can see that we have a signal that fired up and it filtered on all. So what I want to do now, I just want to make sure that whenever this signal runs, it tries to put the filter to all. So there's a new button here. I can click it and it just creates a test on the clipboard. So if I move back into the Jest test here, I can just paste it. And what it gives me is what I need for this test to run. Now, the thing is, if there was some state that was mutated before this signal, like imagine you have multiple signals here, it would actually provide all the mutations necessary to bring the state up to date to run the test exactly as the signal ran in the debugger. What we don't see here, which is also pretty awesome, we'll see that in the next example, is that it also mocks out all the providers. But we'll talk more about that. So the point here now is that if I write expect snapshot and we grab the snapshot to match, what is it? To match snapshot, I think. And we save that. And let's have a look inside here. We have one test that has passed. Of course, it was the first test. But let's look at it. And here we see it. So signal snapshot is an array. And that array is the execution. So what you see here is that there was an action with the name operator set blah blah blah, and there was a mutation in this action, a set mutation on the path filter, and it provided these arguments. And there is also other like primitives here, like provider, which we will see later. But basically, this is the execution. So the thing is, if we change anything now inside the action, like it does the mutation differently or whatever, this would actually fail. And so why do we do this snapshot testing? The thing is, like, especially with actions, they are so decoupled in Cerebral, like they are just functions composed into the signals, and they can run in multiple signals, like with different context. So having this snapshot approach is really valuable, because imagine you have an action that runs in 3 different signals and you make a change for it to work better for one signal. You will be instantly notified that, hey, these other signals has a change as well, or operates differently because of this. So this is actually super valuable to kind of like feel safe when you do refactoring and stuff. Anyways, let's move into the fun stuff. So what we can also do here is when you run a signal, you do that because you want the UI to update. So what we can do here is do tree and renderer dot create. And what we want to create here is, let's see, we want a container, and it's the snapshot controller, and then we want to test the footer here, because the footer is what is kind of like affected by this signal. Like it holds the, let's have a look at it. Well, we can't see it now, but it holds like which page are we on, like which filter is active. So we have this, and then I think it's to JSON like this. And then we can also set an expect for this tree to match snapshots. Okay, so the really nice thing is that when you have a component that is connected to Cerebral, like when you connect the state exactly where you use it, you can do this kind of testing. So we just wrap the specific component that we want to test, in this case the footer. So let's have a look at footer. It's a connected component. And then we can try to save this, and let's see what happens now. And we got a change, yeah, because we changed the test, and it just basically says that this is the same, but we also have now this footer thing. Okay, so we'll just update the test and say everything's okay. And let's look at the snapshot. It has the footer thingy, and it also has the signal. Okay, so let's see. Let's imagine now that I made a change to the app here. So what I want to change is inside sequences, we have the change filter sequence, which we're actually running now. And instead of pointing to props filter, let's just take a normal value here, foo, and I save this. And what happens now is that we can actually see that when this component now renders, it loses its selected class name, because that is what is used to indicate that we are on the all filter. So that's the UI. And then we also see that, okay, the name of the action changed, but also the mutation changed here. So this gives you like really good insight into exactly what changes. And if I just change it back, and it will run, should run green again. Props all. Oh, sorry, like that. And it runs green again. So this gives you like an indication of how we can combine signal snapshots with the components that are affected by those state changes. And let's try to create a new test here. Test should new to do. Okay, we need a callback here. And let's just add a to do. And we look into the signals. Like we could create a test for new to do title change, but we're not going to do that. We're going to do something more fancy. So I'll create a signal test. I'll paste it in. And now we can see some new stuff happening here. We can see that, let's save, so Prettier can do its thing. What we see here is that first it changed the filter to all, and then it changed the title, and then it creates a mock, and it does this automatically. So it creates a mock for id.create, and it gives the value that was used when the signal was executed at this point in time. And then it runs the signal. So what we can do here is basically do the same. We can create a snapshot, and let's see how this snapshot looks like. And we can see that we run an action, and like the signal is actually running. This is really important. It's not like some mocked simulated stuff. It's only it's actually running a controller, changing the state. The only thing that is mocked is the providers. So we see that we have an action that has a name, and then it runs a path. It goes down the true path, runs another action, runs a provider, id.create, and we have mutation here, blah blah blah. It sets the path to, yeah, okay, like you can read this. So let's say that's okay. And then we can, for example, maybe we want to check that the list actually has the new to-do. So what we can do is, let's just do this by copying. So let's import the list. List. Okay. Yeah, and of course we need the actual test here. Let's try to run this. And now it moved the signal test, so it gives an indication about that. But we can also see that now we have the stuff for the list, and we can see that we have like the input checked false, blah blah blah, H, here's the title, and all that stuff. So we just update that and everything's good. So this is, I think this is a really good approach for testing, because you'd spend very little time on this. You can focus on implementing the signal and make your application work. And then you can just copy the snapshot test into an actual test, and then combine it with the UI you want to make sure works correctly related to that signal. And then whenever you make changes to your app, Jest will just let you know that stuff changes. I don't know if you heard about Majestic. I haven't tried it yet, but I think that will be super awesome. It's like an app for Jest that gives you like a really clean UI for following your tests and yeah, that kind of stuff. What's also really interesting here is that it actually automatically also mocks providers that returns promises. So if it returns a promise, if it's rejected or resolved, it will actually mock it. There's like a mock resolved promise and mock rejected promise. But all this just happens automatically. But of course you can like manually create a test. So maybe you want to test the signal execution in different scenarios, where initially it was a resolved promise from HTTP, for example, and then you want to create another test where the promise is rejected. And then you can just copy like the resolved test and make that specific mock rejected. And then create a snapshot for that in case you want to make sure of that. It will also, like the snapshot test, I don't want to call it a framework, but yeah, tool, also throws errors at you if, for example, the mocks aren't running in the order provided. If it tries to run a mock that is not defined, it will tell you that you didn't write a mock for this provider call, and all this kind of stuff. But yeah, I actually think this is ready. I just want to release it to allow people to test it, and let's just call it beta. I need to write some documentation for it. But it would be really awesome to get some feedback on this, and I really hope you like it. I certainly do. Okay, thanks for watching.